Hello everyone, welcome to the video for chapter 12, which is all about understanding weather. So, what do we know about the weather? Well, as pilots, we want to know a lot about the weather because we're concerned about the weather. We don't like things like thunderstorms and icing and clouds and winds, right? So, these are things that are primary concern for us. So, basics about the weather. All weather comes from the sun. The sun heats the earth, often unequally, and that causes weather. So, you got the earth, you got the sun over here, and it heats the earth unevenly, right? You got the more intense part and the less intense part. What happens to air as it gets heated? As air gets heated, it tries to rise. Makes me think back in college, had a professor who was really, really smart, physics professor. He was one of the top 4 physicists in the world. That's what he was rated as by his professors at Harvard when he got his PhD there. Really, really smart guy. And we were looking at this thing called a Jacob's ladder one day, which has the little little arcs. Right? And so we were talking about why does the arc go up? And everyone said it's heat. You heat the air, the ionized air, and then that rises, and that's why the arc goes up. And this guy just couldn't accept that simple explanation, and he was like, oh no, it's got to be this, it's got to be that. And, he was trying to do some calculations to prove why it would go up. And then someone took this thing and they turned it upside down and plugged it in, and the arc still went up. And then he got really mad and stormed out of the room. So, anyway, weather comes from the sun. Sun heats the air rises, and it's that circulation that causes pretty much all the weather that you're going to have. Now, if you look in your book, he'll show you all these different kinds of pictures. Like, okay, so, this is getting heated, and this is going to rise, and it's going to fall. So we got, kind of this motion, and we got something similar here, where it's going around a big circle. That's all well and good, but for our purposes, remember this. All weather comes from the sun, heats the earth, and then there's other factors that come into play as well. Now, when we look at things that we care about, we care a lot about water. Good old H2O, or HOH, depending on who you ask. Now, when we look at water, water has different phases. It can be a gas, liquid, or a solid. By the way, the fact that water is less dense as a solid than a liquid is kind of unusual. Not too many things act that way. And if that wasn't true, we wouldn't have life on Earth as we know it. Everything would be very, very different. Right? Lakes wouldn't freeze over from the top. It would freeze from the bottom up. And life would be very strange. There wouldn't be a lot of fish either, if that's how things work. Okay. So, whenever we have visible moisture, we call that a cloud. So we can say, well, where are these clouds going to be? When do we have these clouds? And how do we get this visible moisture? Well, we get this visible moisture whenever there is so much water in the air that the air has become saturated. So a cloud is just visible moisture, visible water. So how do we get clouds? If the temperature equals this thing called a dew point, you pretty much have a cloud. Now, as you go up in altitude, the temperature, generally speaking, decreases. So eventually you'll get to a point where you're at the dew point. So how do I get a cloud? I can either cool down to the dew point. I got a cloud because now it's saturated, or I can add water to saturate the air. If either of those two things happen, now I'm going to have a cloud. It's that simple. So I can have air flowing over things like water. It can pick up moisture. And we'll talk about a couple of those things later. So, as a pilot, when I talk about clouds, I particularly worry about low clouds. How do I get low clouds? If the temp dew point difference is low, I get low clouds. If this is about 3 Celsius or less, I'm probably going to have low clouds. Why do I say 3 Celsius or less? Because if I look at a standard lapse rate, 3 degrees Celsius, I'm going to have clouds within 1,000 feet or so of the ground. So if the temperature and the dew point spread are very small, I might have to worry about low clouds. Now, Rod talks about things like temperature inversions, where you have something that's like capping that air, it tries to rise, and there's some sort of stagnant layer, and there's different things that can cause that. And when that happens, you can get a temperature inversion where, boom, there's something trapping stuff. And then as this air, in a sense, gets squeezed, if you will, it will heat it up. And you can get temperatures going up, and then temperatures start going down at some point beyond that. Okay. He talks about things like stable and unstable air. The more stable the air is, the less turbulence you have. But you might have less visibility because things aren't moving around a lot. The more unstable the air is, like let's say a hot summer afternoon, now you have good visibility, but you're getting tossed around a lot. So you can get all kinds of issues with things like wind shear as you fly through unstable air. And if you have stable air on top of unstable air, you can have a shear as you go from one altitude to another. as well. All right. So we said all the weather comes from the sun. And we talk a lot about things like high pressure and low pressure. So if I have a high pressure area and a low pressure area, you would think that all of the air would go straight from high to low. And you'd be almost correct. At the surface, it's pretty much what happens. But as you go higher and higher, the surface friction is less. So now instead of going straight there, you get this turning, right? You have the Coriolis force, which is something that Rod talks about pretty early on in this chapter, that causes the winds to swirl. So if I look at these constant pressure lines, or isobars, as they are called, if I have air that wants to go from here to here, now what happens is at altitude, they start to turn because of the Coriolis force. Now what's the Coriolis force? Coriolis force is nothing more than the fact that the Earth is rotating underneath this air, or if you want to be technical about it, like physics, and who doesn't, you can say you have an accelerated reference frame. So you have an inappropriate reference frame which generates this Coriolis effect or Coriolis force, which is not an actual real force. But that's okay. So what happens is around high pressure systems, the air starts to circulate clockwise. Around low pressure systems, it's going to circulate counterclockwise, or for the Brits, the anti-clockwise direction. So if you look at the winds aloft, you'll see on the ground again, it's going to go from straight from here to here, and then it's going to start to shift. So now, as I go up a little bit in altitude, it's going to shift more this direction. And it's going to shift more and more as I go up in altitude. Whenever the wind changes velocity or speed, I should say, and direction, that's a wind shear. Change one or both of those things, speed and direction. That's what we call wind shear. So if I have a high pressure system and a low pressure system, then that's going to change. If these isobars are closer together, the pressure gradient is higher, and I'm going to expect more of an effect as I fly along. Now, one of the things, and I've seen this in loads of books, talk about flying. They're like, I'm flying from here to here, or I'm flying over to this area. I can take advantage of this. And, you know, let's say I was going to fly from here to here. Instead of flying direct, like that, I could take this path where I could get kicked here and then kicked again here. And that'll give me better speeds. In theory, this is true, but I will say this. Most private pilots don't make trips that are long enough that you would actually do this. That's number one. Number two, you have to go up to a pretty high altitude for this to happen. But yes, in theory, it is possible to take advantage of this little push. Okay, other things you should know. High pressure systems, generally speaking, represent good weather. Low pressure, bad weather. So if you're going somewhere and the wind keeps increasing and increasing and it's coming from your left, turn around and go somewhere else because you're flying right into this bad weather here. And that's not what you want. So we talk about different kinds of fronts. So we have warm fronts, we have cold fronts, and what does all that stuff mean? So a front is nothing more than when air masses collide. Right? So what's an air mass? It's a chunk of air that has similar properties. What kinds of properties? Temperature, humidity, and pressure. So if I have cold air, and let's say it's coming up this way, and then I have warm air coming this direction, what's going to happen? Well, that cold air is more dense. This warm air gets forced up, and I might see clouds. The air gets forced up, things cool down, and boom, visible moisture. Well, what if the warm stuff is moving faster? Well, you know, that's the difference between cold fronts, warm fronts. But if I look at cold fronts, these can lead to another one of those things that is not a friend of pilots. Right? So what do we worry about as pilots? Low clouds, wind, especially wind in the surface, turbulence. You know, kind of worry about that, especially we have passengers. And we worry about things like thunderstorms. So a thunderstorm is always going to have lightning. And may have thunder, despite the name. We don't really care about thunder. Can also have hail. Can have updrafts. Downdrafts. Turbulence. There's a lot not to like if you're a pilot about a thunderstorm. I mean, it might be fun to watch from the ground, but not as much fun to watch from the air. So how do we get thunderstorms? We pretty much need moisture, and a lifting action. We need something to drive things up into the atmosphere where things cool, we get these updrafts, and eventually we get downdrafts as well. Okay, so when I look at a thunderstorm, thunderstorms have different stages. We have the building stage. This is categorized By the way, if you see thunderstorms developing in front of you, don't think you can outclimb them. I had a student once, we were going on a trip, and there were some thunderstorms building in front of us. I'm like, what are you going to do? I'm going to climb. I'm going to climb. I'm going to climb. We got up to at least 10,000 feet. And then I finally stopped him. And I said, we're going to turn around. We're not going to complete this flight. Because he kept trying to outclimb a thunderstorm, which you will not do in a small aircraft. So that's the building stage. Then we get to the mature stage. Mature stage, you've got updrafts and downdrafts. So if I think about, let's say I want to fly through this, well, you shouldn't be flying through the clouds at all as a VFR pilot. But let's say I'm feeling extra foolish that day. If I fly through this during the building stage, I'm going to have all these updrafts. It's going to shoot me up higher than I probably want to be. And I might not even be able to keep my plane at a constant altitude. Now, if I look at mature stage, now I've got things going up and down. That could be some wicked turbulence. By the way, usually the interface of a cloud is the worst part. So I come in and like, woo! So I try to push the nose down and then bam, I hit these downdrafts. And then coming out the other side, I'm hitting updrafts. Usually the turbulence from things like this isn't enough to destroy an airplane, but a pilot's overreaction to turbulence can be. I just heard from a friend of mine that, I won't say what, but a professionally flown aircraft received some damage, not from storms, but from pilot abuse, where the trim tab had separated from the tail, from the elevator on that aircraft, because pilots have been exceeding its speeds. So it's usually pilots that destroy things, not as much weather. I'm not saying it's impossible for weather to destroy an aircraft. I'm just saying usually the pilots at least help it along. All right, so mature stage, how do you know you're in the mature stage? You start to see precipitation on the ground. So you start to see rain, and then there's the dissipating. Or it's all downdrafts. It's basically raining itself out. Why do you need to worry about that? Severe downdrafts, if you're close to the ground and you're hitting these downdrafts, now you can't avoid the ground, and that's bad. If you fly over a thunderstorm, well, first of all, good luck. I just said you can't really outclimb these very well. If you fly under it, that's not great either. So you're like, oh, I'll fly right around it. There's these things called squall lines. So what's a squall line? We were just talking about fronts. We said we have our cold front here. It's hitting the warm air. Now, if you look at your book, he talks about this on page L37, and he has a nice little picture of this pressure wave. So this thing is moving so fast. It's kind of like the waves on the bow of a boat, if you will. They precede the boat by a little bit. The faster you go, the more that is a factor. So you get these pressure waves, so you can be miles away, maybe 30 miles away from this thunderstorm. So over here, we got this big, nasty thunderstorm. stuff's happening. Well, then 30 miles away, I have this little pressure peak that's pushing stuff up here, and now I have, squall line thunderstorms. So it's something you should be aware of. All right. So we said we don't like low clouds. We don't like turbulence, high winds. We definitely don't like thunderstorms. What are some other things that we should worry about? Well, we can have warm fronts as well, where you have warm air that's essentially overtaking cold air, if you will. And that's going to give us slightly different weather. Can I get thunderstorms from warm fronts? Yep. I certainly can. So now, let's say I have my cold air. It's kind of moving this way, but not real fast. And I got my warm air that's overtaking it. So again, it's going to get driven upward. And that's going to give me nasty storms. Just slightly different. Don't tend to see things like that squall line, thunderstorm, things like that. But I can get that. And of course, I talked about cold fronts, warm fronts, and then you have a stationary front. Stationary front's basically a standoff. You have two fronts that kind of hit each other and they're just stuck there. All right. Other things that he talks about. He talks about different types of thunderstorms, like air mass thunderstorms, orographic thunderstorms, frontal thunderstorms, embedded thunderstorms. Again, you shouldn't be flying in the clouds anyway, so shouldn't be an issue for you. Talks a little bit about virga. Virga is just precipitation that's sort of trailing a cloud. Virga actually stands for variable intensity rain gradient aloft. It's rain that never didn't quite make it to the ground. So when you're flying, you might notice it as you're flying along. You might just see, oh, what do you know? There's like rain that's trailing this cloud out there. Talks a little bit about wind shear. We've talked about this a little bit before. When it comes to wind shear, as you're coming into land in particular, you can get structural turbulence. That's wind whipping around structures and stuff on the ground. It can be man-made or it could be trees and ridges and things like that. We have convective turbulence. If you're flying a really light aircraft like a Cessna 150 or an ultralight, on a summer day, if you go across a blacktop road, you can actually feel the thermal from that. You're just like, boom, boom. Right? And that's another common occurrence while you're flying. Talks about things like winds going across a mountain. Generally speaking, if you're within 1,000 feet of the top of a ridge, you can get affected by the winds blowing across it. So, here I have some sort of a mountain. Wind is blowing this way. Wind gets forced up the mountain. That can cause things like clouds to form. And then we can get winds kind of going like this. And that forms lenticular clouds, sometimes called standing lenticular clouds. And then down this way, now things get really wild. And you get rotor clouds. You did not want to fly through these. Had some pretty wild rides. Bad turbulence. So, if the wind is blowing this way, how do you want to approach the ridge? Now here in Bloomsburg, if the winds are blowing and it's a crosswind and we're using runway 27, I always tell people, hey, hit that ridge perpendicular if you can. Why is that better? Well, if there's any weird turbulence, it's going to hit both wings at the same time. When if I go at an angle, it's the one wing and then it hits the other wing, and plane's doing this. And the passengers get kind of upset when that happens. All right, other things we worry about. Fog. I think Rod also mentioned something called a microburst. A microburst is where you have this boom, intense downdraft. It's very localized, often associated with thunderstorms and such. I was at an airport in Iowa some years ago when a microburst hit the airport. It took out a row of hangars, and I was maybe 100 or 200 feet away from all this action. And it was incredible. I actually came out of the hangar, drove around the corner, turned around, went back, and talked to my friend. We were in the hangar doing an annual, I think on a Saratoga. It's either Saratoga or Malibu. I don't remember which one at the time. But anyway, so we were in the hangar working, and the hangar was, the doors were kind of shaking a little bit. So I delayed my departure. And when I came around the corner, I saw that this was a row of hangars that was just gone. And all the planes that were in that hangar, some of them had been flipped over, some of them had been thrown to another row of hangars, and some were even thrown over a row of hangars into a third row of hangars, pretty far away. So it was a pretty bad thing. Anyway, so that's a microburst. The last thing in this chapter that Rod talks about is fog. So what's fog? Fog's just a low cloud. We already talked about how we get fog, how we get low clouds, how we get clouds at all. Saturate the air, cool it to the dew point. Two basic ways. Now he talks about different kinds of fog, but honestly, I've never thought that you really needed to know the different kinds of fog. What are they called? It's just fog. Right? If you know how it's formed, I think that's good enough. Now, maybe the FAA will disagree. When you take your knowledge test, you should probably know, what these different kinds of fog are. I would review it right before I took my test. So, first one he talks about is radiation fog. So, radiation fog, you have the Earth radiating its heat away, and that's how it gets its name. On those calm, clear nights. So the Earth cools. As the Earth cools, then it condenses the moisture, and we get fog. We have things like advection fog. And sometimes we call this sea fog, where you have water.
All right, everyone. So as I was just about to wrap up this video, my battery died on my camcorder. So sorry about that. and I'm feeling a little lazy, so I was literally just about to finish this whole chapter. So what I was going to say is just, there's different kinds of fog. We talked about advection fog, and we talked about radiation fog. We have upslope fog, where if the air gets pushed up a slope, it gets cooled, and it gets cooled to the dew point, and you get fog that way. We have precipitation-induced fog, where the warm rain's falling through cooler air, and it can saturate that air. We have ice fog that is similar to radiation fog, except for the air temperature is like way below freezing. And then we have steam fog. So what happens in steam fog? We have this dry, cold air that passes over a warmer body of water. And as that water evaporates, it causes the air to get saturated. So those are other kinds of fog. And again, with fog, the important thing is that you know how fog forms. So you either add moisture to saturate it, or you cool it down to the dew point, and that's how you get fog. And what is fog anyway? It's just a cloud that's low to the ground. All right, so that brings us to the end of chapter 12.